All right, today we're going to be looking at section 7.1, which is right triangle trig. All right, first thing is a trig ratio, and this is what we did at the very beginning of this class. A trig ratio is a fraction of the lengths of two sides of a right triangle. And for this is where SOHCAHTOA comes into play. So just remember, SOHCAHTOA, S-O-H is for sine. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So we're going to look at these first four problems right here, and we're going to try to find the trig ratios based off of these triangles. Now remember, for right triangle trig, we can only use SOHCAHTOA. We can't use it for any other type of triangle. All right, so looking first at number one, since this is a right triangle, we have to do Pythagorean theorem like you had to do yesterday to find this missing side. I'm missing this leg. Remember, Pythagorean theorem is a squared plus b squared equals c squared. So I've got 3 as a leg. I don't know my other leg. And my hypotenuse happens to be 5. So we talked about before, do I add or subtract these squares? Here I subtract these 2 squares since I'm given a leg and a hypotenuse. So if I subtract these 2 squares, I can take 5 squared, subtract 3 squared, and that's going to give me out 16. But remember, I got to take the square root of this number. So the square root of 16 gives me 4. Now you should already know here that this is a 3, 4, 5 Pythagorean triple triangle. So based off of this angle that's in the bottom left-hand corner, I'm going to find each of these 3 trig functions. So my first one is sine. Well, to find sine, we do opposite over hypotenuse. So opposite is 4, hypotenuse is 5. So the sine of theta in this problem is just 4/5. The next one we're going to find is secant. Well, secant's reciprocal is cosine. If cosine is adjacent over hypotenuse, then secant's going to be hypotenuse over adjacent. So here's hypotenuse. Adjacent is the closest leg to that theta, which is 3. So this is 5/3. And last one on number 1 that I need to find is cotangent. Well, cotangent's reciprocal is tangent. Tangent is opposite over adjacent. So I need to do adjacent over opposite. So here's adjacent, closest to it 3. Here's opposite 4. So cotangent is 3/4. All right, so there's number 1. All right, now, next thing we go to is number 2. Solving number 2, same thing. I'm given a hypotenuse and I'm given a leg. So I need to subtract these 2 squares. Now, first thing I have to do is I have to square this hypotenuse right here. If I take 4 on the square root of 2 and square it, I have to square the 4 and I have to square the square root of 2. So 4 squared is 16. The square root of 2 squared is 2. So that's 16 times 2, which is basically 32 right here. And then I square the 2, so that's 4. So I've got 32 minus 4, and that's going to give me out 28. So this over here is the square root of 28. But first thing I need to do is break this down. 28 is 4 times 7. So this breaks down into 2 on the square root of 7 simplified. So now I'm ready to go and find each of these 3 trig properties right here. First thing I want to find is cosine. Cosine is adjacent over hypotenuse. So here's theta. It's up at the top now. Adjacent is what I just found, 2 on the square root of 7, and my hypotenuse is 4 on the square root of 2. So this is 2 on the square root of 7 over 4 on the square root of 2. All right, 2 things I'm going to do at the same time. First thing I'm going to do is reduce this 2 and 4 to give me 1/2. Then I'm also going to multiply by the square root of 2 to rationalize this denominator. So remember, this right here gives me 1/2. I'm going to reduce it there. And then if I multiply top and bottom by the square root of 2, I get 7 times 2, so the square root of 14 is in the top. Remember, if I multiply the square root of 2 times the square root of 2, it gives me 2, but I already have a 2 over here, so 2 times 2 gives me 4. So that's the square root of 14 over 4. Next one I need to find is cosecant. Cosecant's reciprocal is sine. Sine is opposite over hypotenuse, so I need to do hypotenuse over opposite. So here's hypotenuse, opposite side across would be 2. So this is hypotenuse, 4 on the square root of 2, over my opposite side, which is 2, and then I can simplify. 4 divided by 2 gives me 2. So this one simplifies into 2 on the square root of 2. Last one I need to find is tangent. Tangent is opposite over adjacent. So opposite goes across, adjacent right beside here. So I'm starting off with 2 on the top as my numerator. And then my adjacent side is 2 on the square root of 7. Now to simplify this, the 2 2's go away. So I'm really left with 1 over the square root of 7. And then rationalizing that gives me the square root of 7 over 7. So there's number 2. All right, now, next one I'm going to is number 3. A little bit tricky right here. On number 3, the only thing they give me is the hypotenuse. But they also tell me that these 2 angles are congruent. Well, if these 2 angles are congruent, and this is 90 degrees, this is a 45, 45, 90 triangle, which means these two legs also have to be congruent as well. Now, things that we've talked about with 45, 45, 90, my sides are 1 square root of 2, or you can do your formula. Hypotenuse equals the square root of 2 times your leg. But right here, since these two things equal each other, then these two sides right here have to be whatever number is in front of here, since I got the square root of 2 attached to it. So this side is 18, and this side is 18. Another way you can look at it is using the Pythagorean theorem. So if I know if this side is, let's say, x, that means this side also has to be x. So I could do something like this. X squared plus x squared equals 18 on the square root of 2, all squared. Well, x squared and x squared, those are like terms. So this right here would be 2x squared. Remember right here, if I'm going to square this, I have to square the 18 first, which is going to give me 324. And then I got to square the square root of 2, which is going to give me 2. So I've got 324 times 2, and that gives me 648. So I can solve this by dividing by 2 to get rid of that coefficient that comes in front. And that gives me 324. And now from here, all I have to do is just take the square root. So the square root of 324 is a perfect root, which is that 18 that we saw right here. So that's a different way to talk about it. All right, first trig function we need to find is cosine. Cosine is adjacent over hypotenuse. Well, here's my theta. Adjacent closest to it, hypotenuse. So this is 18 over 18 on the square root of 2. Simplifying, these two 18s go away, so I've really got 1 over the square root of 2. So rationalize gives me the square root of 2 over 2. Cosecant. Cosecant's reciprocal is sine. Sine is opposite over hypotenuse, so I need hypotenuse over opposite. So hypotenuse, opposite across. So I've got 18 on the square root of 2 on top now, and then 18 on the bottom. My 18s go away. No need to rationalize here since the root is in the top. So that's just the square root of 2. Last thing I need to do is find is tangent. Tangent for an isosceles triangle should be easy. You got opposite over adjacent. Well, you got 18 divided by 18. Same thing divided by itself is always 1. All right, last one we got right here is number 4. Once again, they give me hypotenuse and they give me a leg. So I need to subtract these two squares. So I'm going to take 18 squared minus 8 squared, and that's going to give me 260. So this right here is the square root of 260. Now, next thing I have to do is try to break this 260 down. 260 is not a perfect square, so I got to break it down. So I'm trying to find a perfect root that goes into 260. So first thing I'm going to check is just some different numbers. So first thing I know is that 4 goes into it. So this right here is the square root of 4 times the square root of 65. And I'm going to look to see, I want to leave 4 alone since it's a perfect square. So then I can take 65, and that's just going to be 5 times 13. So this can break down into 2 on the square root of 65 in its most simplest form. So first thing I want to find my trig function is sine. Sine is opposite over hypotenuse. So here's my theta. Opposite is here. Hypotenuse is 18, so I really didn't have to have that adjacent side. So this is 8 divided by 18. Next thing I need to do is just simplify that 8 divided by 18, and that's going to reduce right here to 4 over 9. Next thing I want to find is cosine. Cosine is adjacent over hypotenuse. Here's that adjacent side, so I'm going to use 2 on the square root of 65 over my hypotenuse, which is 18. So 2 on the square root of 65 over 18. 2 and 18 can be simplified. 2 goes into both of these, so this reduces into 1 over 9. So this simplifies into the square root of 65 over 9. All right, last one I have to do is tangent. Tangent is opposite over adjacent. So here's opposite, 8. Here's adjacent, right here, 2 on the square root of 65. So I've got 8 over 2 on the square root of 65. I look at 8 and 2, and those can be reduced. 2 can go into both of these, so a 4 is left in the top. Then I have to rationalize this denominator. So I'm multiplying top and bottom by the square root of 65. So this is 4 on the square root of 65 over 65. Now, if this 4 and 65 could be reduced, I would reduce it. But in this problem, it can't. All right, so that's just me basically reviewing trig ratios and how to use SOHCAHTOA, and also finding those reciprocal functions, secant, cosecant, and cotangent. All right, next thing we're going to look at is complementary angles. Complementary angles are 2 acute angles whose sum is 90 degrees. So when I add them up, you get 90 degrees. These are also called cofunctions. So on my reference sheet right here, these are my cofunctions if you can see them. So sine's cofunction is cosine. Cosine's cofunction is sine. Cosecant's cofunction is secant. Secant's cofunction is cosecant. Tangent's cofunction is cotangent, and cotangent's cofunction is tangent. So this is what I'm going to use in order to solve these problems. So basically, the sine of 30 is the same thing as the cosine of 60 if you look at your unit circle. So I'm going to flip back to my unit circle for a second. So on the back, we got our unit circle right here. So if I'm going to look at cosine first, all right, so let's look at 30 degrees. The cosine of 30, remember, is my x, so that's the square root of 3 over 2. Remember, we said it is a cofunction, so if I take 90 and subtract 30, I get 60, and cosine's cofunction is sine. So the sine of 60 is the same thing, square root of 3 over 2. That's where cofunctions come from. All right, so looking at right triangle trig, get my camera straightened out here. To solve these complementary angles, the first problem I'm doing is number 1. Now, to solve these problems, I've got to make sure that these two angles are equal to each other before I even begin. So 38 and 52 do not equal each other. So I've either got to change 38 to 90 minus 38, or I've got to change 52, 90 minus 52. Now, both of these right here add to give me 90 degrees. 38 plus 52 is going to add to give me 90, which allows me to use these complementary angles or these cofunctions. Sine's cofunction is cosine. Cosine's cofunction is sine. So I can do either one of these. I'm just going to start with this first one right here. So if I want to change this 38 to its cofunction, the first thing I have to do is take 90 and subtract 38. 90 minus 38 gives me 52. But if I change the angle, I've also got to change the trig function. Sine's cofunction is cosine. So this is the same thing as the cosine. 90 minus 38 gives me 52. And then I'm going to keep this other one along. So this is just the cosine of 52. Well, as you notice, these two things are the same. If you take the same things and subtract them, my answer on number 1 comes out to be 0. All right, number 2, 80 and 10 add to give me 90. So those are complementary angles, which allows me to use cofunctions. So I can change the top. 90 minus 10 gives me 80. But if I change the top to 80, I got to change cosine to its cofunction, which is sine. Or I can come to the bottom and do 90 minus 80, which gives me 10. But if I change the angle on the bottom to 10, then the sine cofunction has to change to cosine. I'm just going to start with the top. So I'm going to first take this 10 and do 90 minus 10, which gives me 80. So when I change this to 80, cosine's cofunction is sine. So this is the sine of 80. I'm going to leave the bottom alone. Sine 80. Now I have the same angle, so I can simplify. Same thing divided by itself. This solution comes out to be 1. All right, looking at number 3. When I go to solve number 3, the first thing I notice is 70 and 20 add to give me 90. So that means that I can use cofunctions here. Several different ways that you can do this problem right here. First way I could do it is I could say 90 minus 20, that gives me 70, and change cosine to sine. Now, since it's squared, the squared also has to be within my problem as well. Another thing I can look at is I can look at this entire function right here, and we've talked about trig properties already. 1 minus cosine squared is actually a trig property, which is sine squared. So I could change this to actually sine squared 20, and then I've got minus cosine squared 70, just leaving that alone. All right, now I can do what we just did with cofunctions. 70 and 20 add to give me 90. Now I'm going to change the first one. Changing this one, 90 minus 20 gives me 70, but I've got to change sine to its cofunction, which is cosine. So this is cosine squared 70 minus the same thing, leaving that one alone. Same thing minus itself, once again, comes out to give me 0. All right, coming over here to number 4. Number 4, using my properties, I could change tangent to sine over cosine, so that'd be sine 20 over cosine 20. Or since this is 20 and this is 20, I can just change this angle, because 70 plus 20 gives me 90. So I'm going to change this angle. 90 minus 70 is 20, but since I changed this angle, the cofunction for cosine has to change to sine. So I've got the tangent of 20, let's leave that alone, minus, we're going to change this one. So cofunction for cosine is sine. 90 minus 70 gives me 20, and then I've got over cosine 20. Now you should know, looking at this right here, sine over cosine gives me tangent. So this is just the tangent of 20 minus tangent of 20, same thing minus itself, gives me 0. All right, then we got number 5. Going with number 5, first thing I notice is this right here, 35 and 55, actually add to give me 90. So this is cofunctions as well. So first thing I can do, here's a 35, here's a 55, so I can change everything in this problem to 55 degrees, which means these two have to change. Or I can change everything in this problem to 35 degrees, which means these two have to change, okay? So I'm going to change everything to 35. Really doesn't matter, so I'm going to underline these two. These two are going to change to 35. Now, where's 35 coming from? 90 minus 55 is actually 35. That's that cofunction that I can use to solve this problem. So cosine 35 is going to stay the same. Sine of 35, this 55 now is going to change. 90 minus 55 is 35. Sine is going to change to cosine since this is cofunctions. This is the cosine of 35. Plus, let's leave sine of 35 alone because remember, I want everything to be 35 degrees. Then I'm going to change this angle. 90 minus 55 gives me 35, but I got to change sine's cofunction to cosine. This problem is written wrong. All right, so let's look at number 5. Be careful, I typed this out wrong. So this is cosine 35, sine 55, plus sine 35. This should be cosine right here, y'all. So let's make sure we change that. So starting the problem. All right, now we can get everything in terms of here. So we got cosine 35, right here, sine stayed. Now this is 55, so I'm going to change it to a 35. The cofunction for cosine is now sine, so this is the sine of 35. And now we can simplify. Cosine times cosine, this is cosine squared 35. Plus sine times sine, that's sine squared 35. And then cosine squared plus sine squared, there's my property. Sine squared theta plus cosine squared theta equals 1. Using those properties that we talked about earlier in this year. All right, last thing we have to cover right here is solving right triangles. Now we did this back at the very first day of trig. So if you take your notes and look back at the very first thing we did, we actually did solving right triangles. So the first thing we do for solve a right triangle is use the Pythagorean theorem. A squared plus b squared equals c squared. Second thing we do is look for our special right triangles, 45, 45, 90. This is 1, 1, square root of 2. Or we also have a 30, 60, 90. So this is 1, 2, right here for this 90 degrees, and then the square root of 3. So 1, square root of 3, and 2 are those three sides. And then we also have SOHCAHTOA. Now that's for a right triangle. To solve for a missing angle, we always use inverse trig functions to get us to our solutions. So on all of these problems, 1 through 6, I'm going to try to write really small, and we're going to solve each of these problems and solving for the missing angles and its missing sides. A lot of this stuff is going to be done using my calculator. So let's look at number 1 first. Easiest thing to solve for is this missing angle. Since this is 90 and this is 40, I know there's 180 degrees in a triangle, so I can take 180 minus 90 minus 40, or since this is 90, these two angles add to give me 90, so really I could just say 90 minus 40. So that angle right there, beta, comes out to be 50 degrees, 90 minus 40. All right, next thing I have to do is solve for these two sides right here. Can't use Pythagorean theorem because I'm missing two sides and not one side. So I've got to go with SOHCAHTOA in order to solve problems down here. So I'm going to do my kind of work down here at the bottom. So first thing, let's go with A just because it comes first in the alphabet. I'm going to use 40. Across from 40 is my opposite side, so that's A, and adjacent to it is 2. So I'm looking for a trig function that involves adjacent and opposite. Well, flipping it over, opposite over adjacent gives me tangent. So the tangent of my angle 40 equals opposite, which is A, over 2. To solve this problem, all I'm going to do is multiply by 2. Now, first thing you got to make sure in your calculators that your mode is set to degree mode. If it's not, you got to come over here and change it over to degree mode. Now, in my calculator, I'm going to type in 2 tangent 40. So 2 tangent 40. And we're going to round to the nearest decimal, nearest one decimal place for sides. So this right here gives me 1.7. So it's 1.67. We're going to round that to 1.7. So A in this problem is 1.7. Now, since I had to round A, I'm not going to use Pythagorean theorem to find C. I'm just going to set up a new SOHCAHTOA in order to get C all by itself. So looking at C, this is hypotenuse. Still want to use that 2 right there, which is adjacent. So now I need adjacent over hypotenuse. Adjacent over hypotenuse is cosine. So my other trig function is going to be cosine 40 equals adjacent, which is 2, over hypotenuse, which is C. Now to solve this, I need to multiply by C and then divide by cosine of 40. Or, remember what we talked about, if my variable's in the bottom, all I really have to do is switch these two things. So in my calculator, I'm going to type in 2 divided by the cosine of 40. So 2 divided by the cosine of 40. And that gives me out a side, once again, rounding to the nearest tenth, one decimal place, is 6. So this is 2.6. So C in this problem equals 2.6. So there's my 3 things I was missing in problem number 1. All right, now going to problem number 2. Problem number 2, the easiest thing to solve for is this missing side. They give me 2 sides, so Pythagorean theorem works best. Since these 2 are my legs, I'm just going to add up those squares. So 2 squared plus 3 squared, 2 squared is 4, 3 squared is 9. So 9 plus 4 gives me 13, so C is just the square root of 13. So you can leave C as the square root of 13, or you can type that into your calculator around to the nearest tenth, which is 1 decimal place, and this still comes out to be 3.6. So there's C. All right, next thing I have to find is alpha or beta first. I'm just going to go with alpha since it comes first in the alphabet. All right, so to solve for alpha, I need to use a trig ratio. So adjacent to alpha is 2, opposite alpha is 3. So adjacent and opposite, or in my case, opposite over adjacent is tangent. So I'm going with the tangent of alpha equals opposite, which is 3, over adjacent, which is 2. Now, to solve for an angle, like we said right here, you have to use an inverse trig function. What's the inverse of tangent? Well, tangent inverse. So in my calculator, I'm going to type in tangent inverse of 3 divided by 2. Now, this is an angle. So angles, we're going to round to the nearest whole number. So my nearest whole angle right here would be 56 degrees. So we solve for alpha. So alpha is 56 degrees. Easiest way to get beta now is just to subtract. Since this is 90, these two have to add to give me 90. So 90 minus 56 gives me 34. So beta in this problem equals 34 degrees. And I've solved for all 3 missing parts of this triangle with my work right here to help me out. All right, going to number 3. Similar to number 2, they give me 2 sides. I got to solve for my missing side. So they give me my 2 legs. I'm going to add up those 2 legs. 20 squared plus 21 squared gives me 841. So if I take the square root of 841, that gives me out a perfect root. So C right here just equals 29. Next thing I'm going to do is solve for these 2 angles. So alpha and beta, doesn't matter which one you do first. I'm just going to go with alpha. So alpha right here, I could actually use this 29 since I have my hypotenuse and I did not have to round. So I'm going to still stick with what I was given though. So opposite is 21, adjacent is 20. So I'm going to go tangent alpha equals opposite 21 over adjacent 20, and in my calculator I'm going to type tangent inverse. So tangent inverse of 21 divided by 20, and that gives me out an angle rounded to the nearest whole number is 46 degrees. So alpha is 46 degrees. Easiest way to find beta is just to subtract now. So 90 minus 46 is going to give me out 44. So beta in this problem is 44 degrees. Pretty simple. All right, going to number 4. Number 4, easiest thing to solve for is this alpha right here. So if this is 60, 90 minus 60 gives me 30. Now I notice that this is a 30, 60, 90 triangle, so I can use my proportions to set me up to solve here, or you could go back and use SOHCAHTOA. Either one's fine. I'm going to go with my proportions so we know how to solve these. All right, so across from my hypotenuse is always the side 2. Across from 60 is always the square root of 3, and across from 30 is always 1, and that's just from smallest to largest. 1 square root of 3 and 2. Now, first thing I need to solve for is A or B. Really doesn't matter, but I'm going to set proportions up to solve for this. I'm going to go with my triangle based off of the triangle that I drew kind of sitting on the outside. So hypotenuse first. Let's do this. 4 over 2. 4 divided by 2. We're going to solve for A first equals A over 1. Now to solve this, this one's really actually easy right here because this is just really A and this is just really 2. So A equals 2. Another thing you could do is cross multiply. So you could say 2A equals 4, or 2A equals 4, then A once again still equals 2. Now, solving for B, I can go ahead and set this proportion up right here. Remember, I did 4 over 2, A over 1, so I'm going to go B over the square root of 3. And then I'm looking at these right here. So crossing this out, I'm looking at this. So here I will cross multiply. So here I got 2B equals 4 on the square root of 3. And all I have to do here is just divide by 2. When I divide by 2 over here, that's going to give me 2 on the square root of 3. So B in this problem equals 2 on the square root of 3. If I type that into my calculator and just round to the nearest decimal, I get out 3.5. So regardless of how you did it, SOHCAHTOA or using your special right triangles, you should still get these 3 solutions out as part of your answer. All right, moving on to number 5. They give me 34 degrees. Easiest thing to solve for is this beta. So I'm going to take 90, subtract 34, and that's going to give me 56. So beta equals 56 degrees. Next thing I need to do is solve for one of these 2 missing sides right here. So I'm going to use 34. I'm going to solve for B first since it's just right here beside it. So B right here is adjacent Across from this is 4, so that's opposite. So I need opposite over adjacent. That's tangent. So tangent of my angle 34 equals opposite 4 over adjacent, which is B. Since my variable's in the bottom, all I'm going to do here is just divide now. So 4 divided by the tangent of 34 is what I'm typing into my calculator, and that gives me out 5.9. Remember, this is a side, so I'm rounding to the nearest tenth. 5.9. Last thing I have to solve for is my hypotenuse. I don't want to use this 5.9 because I rounded, so I'm going to go back to SOHCAHTOA using this 34. C is my hypotenuse. 4 across from it, that's my opposite, so now I need opposite over hypotenuse. Opposite over hypotenuse is sine, so the sine of 34 equals opposite 4 over hypotenuse C. Once again, since this is in the denominator, I'm going to divide. So 4 divided by the sine of 34 gives me out 7.2. Now I got 7.15. But the 5, let me show you this. But this 5 is going to round this one up to a 2. So that's 7.2. So that was C. So C is 7.2. All right, last problem. Here we go. Number 6. I'm missing one side. That's what I'm going to solve for first. And then I'm also missing 2 angles. To solve for this missing side, I'm going to go with the Pythagorean theorem. All right, using my calculator to solve this. Hypotenuse first. So 12.5 squared. I'm going to subtract 6 squared because I was given a hypotenuse and a leg, and that gives me out 120.25. But remember, I got to take the square root of that, and rounding to the nearest tenth, this 6 is actually going to bump this up. So when it bumps this up, it bumps the whole entire thing up. So A actually in this problem equals 11. All right, next thing I need to do is solve for alpha or beta. Doesn't really matter which one you solve for first. I'm just going to go with alpha, and I'm looking at 6. 6 is my adjacent side. 12.5 is my hypotenuse. So adjacent hypotenuse, that's cosine. So cosine alpha equals adjacent 6 over hypotenuse 12.5. To solve for an angle, I got to do the inverse function. So in my calculator, I'm going to type in cosine inverse of 6 divided by 12.5. Just leave that as a decimal. Here, this is an angle, so I'll round to the nearest whole number. So this is 61.3. So basically, that becomes 61. So alpha equals 61 degrees. Last thing I have to do is solve for beta. Well, since I have this angle, all I got to do is subtract. So 90 minus 61 gives me out 29. So beta in this problem is 29 degrees. And we've solved right triangles.